Hello everyone, welcome to my YouTube channel Programming with DPwala. Hope you all are doing good. So let's start with the today's Leetcode weekly contest 388 analysis. So today's contest was relatively a good contest. The first three problems were very easy to implement. When we talk about the last problem, it is a very good one and very interesting one. Very few people is able to solve that. So let's discuss all the entire four problems and discuss what the approach is. So let's start with the very first problem. So here the first problem is apple redistribution into boxes. So here we are given an array apple of size n and an array capacity of size n. So there are n packs where ith pack contains apple of I apples and m boxes contains ith boxes with a capacity of I apples. So here we need to return the minimum number of boxes that we can select to redistribute n packs of apple in the box, and we need to minimize the boxes. So let's discuss this first example. The apple array is 132. So here we are having a apple array 1, 3, and 2. And our capacity is 43152. 4, 3, 1, 5, 2, 2. So here what we need to do? We need to minimize the boxes and store all these apples. So first step is to calculate the total apples. So total apples is 3 plus 2, 1, say, 6. That is 6. So here, what we need to do, we need to minimize the boxes. So we will start with the box with the maximum capacity so that it can fill the apple. So first we will sort it. 1, the 2, 3, and 4 and 5. So we will start with the end element. The reason is that after sorting, the end element is the maximum capacity one. So start with 5. So we will check that whether our total apples is less than equal to this capacity. No, it is not. So this box is not sufficient to or let's say store all these apples. So we require one more apple. So we will be maintaining a count. So we will be requiring this box as well, but this is not sufficient. So now move towards the next box, that is 4. So here our now box capacity is 5 plus 4, that is 9. Whether it is enough to store all these things, right? 6 less than 9. Yes. So we'll be requiring this box as well, but this is sufficient. Sorry, 1 here. Here it should be 1. So a total count is 2. Means two boxes are required. That is capacity with 5 and capacity with 4. So this is a very simple problem. So approach is that first store all the total number of apples, then sort the capacity array. And the last element is the maximum capacity one. So we'll be iterating from the last. We'll be storing the capacity of that element and incrementing the count of boxes, and we'll be checking that whether our total boxes are greater than equal to total apples. If yes, means we need to return the count. So we break from it and we will return the count. Otherwise, we need to run again. So this is the approach, and this is the very simple one. And let's move towards the second problem from this contest. So I will suggest that whenever you are solving a lead code contest, so at every so always try to solve the starting problems very rapidly. This will save your time for the harder problem. Right. So let's discuss the second problem, which is maximum happiness of selected children. So here we are given an array happiness of length n and the positive integer k. See here, there are n children standing in a queue where ith child has a happiness value of happiness of I. What we need to do, we want to select k children from the this n children in k turns. And each turn, when we select a child, happiness value of all the remaining child that we haven't selected will be decreased by 1. And we'll be decrementing the by 1 only when our child happiness value is positive one. If it's big 0, we can't decrement it. The reason is that it will be comes under negative. Happiness can't be negative. So we need to return the maximum sum of the happiness value of selected children by searching the k children. So let's see this example. So here happiness is 1 to 3 and k is 2. So here our happiness is 1, 2, 3 and k is 2. right? So here what we need to do, we need to maximize the happiness in k turns, right? So at first k turns, right, will be decrement k by 1. So first 2 is the one and will be decrement by 1, right? And we'll be at this now position. So our current happiness is 3, and they what they have told, after you are at current one, we will take this happiness and we will and you will decrement all the other happiness that you have not chosen. Now our array becomes 0 1 at this step after taking 3, as you see that. Now we will be at this position. Now we will again decrement k, means this is the last one as k becomes 0. So we'll be taking this one, and as they have mentioned that you can't make the happiness negative. Yeah, if it's 0 means we need can't be decremented further. Now our array is 0, right? And even k is 0, so we can't further do it. And your array becomes don't consist of the positive elements greater than 0. So our count is 4. So maximum happiness that can be built is 4. So what we need to do, you need to sort this array first on the basis of happiness. You need to traverse it from the last, because last element is the maximum happiness one, and you need to run it for the k turns. But every time you need to decrement one, right? So when you are at here, so you need to decrement other elements by one. So what for this, what we will do, we will create one variable and we'll be incremented count one by one, rather than every time setting the array element and decrement the element. So the approach is here. So here you can see, I have taken count variable, answer, and current one. I have sort the happiness array as I mentioned. We will be traversing it from the last, because last element is always a maximum happiness, and we need to maximize the happiness, as you here you can see, right? Maximum sum of the happiness values, right? So what here we I have done, if our count is less than k, count is nothing but total k value, total turns till now. What is the count of the total turns? If it is equal to k means at that time we need to break. If it is less than k means we need to further try, calculate. If our happiness of I minus current value is in the sense that, as for the particular element to be included in the count, we need to decrement for the others element as well, right? If it is greater than 0 means, as they have mentioned that it can't be negative, cannot be negative happiness. So when it is greater than 0, at that time we'll increment it answer. And as I mentioned that we'll be maintaining one current variable, that at every step what we need to do, when whatever the element we are not taking it, we will be decremented by one. So right, this is the one which will be storing current, and at most that times will be decremented the current value. Let's say we are at 2, so we'll be decrement it by 2 times. The reason is that for whenever we are taking 3, at that time it has been decremented, and then whenever we are at that means it will be decremented once only for when we are at 3, right? For that we are maintaining the current one. At last we'll be returning answer. It's a very simple one and just an implementation problem, and you can see that lot many people able to solve it. So rather than discussing more here, we'll be uh, analyzing the fourth and the third problem, which is a very good one. So let's move towards the third problem. Hope you got the approach for the second one. The third problem is that shortest uncommon substring in an array. This is, I can say this problem is just an implementation one. No need to be here. No such at higher data structure is required. Just a few basic ones are required, and you need to just implement it properly. So you can see we are given an array ARR of size n consisting of non-empty strings. We need to find a string array answer of size n such that answer of I is the shortest substring of array that does not occur in any other strings in the array. So what they are saying, let's discuss with the example. So I'll be taking this CAB. So what they want to say here. So what they're trying to say here is that CAB is the first string in the first test case. So I will try to explain that. So CAB, right? So what are the possible substrings for this? The possible substrings are C, CA, CAB, right? Correct. And when we start from A, the possible substrings are A, AB, and for this one is B. The total possible substrings possible for this CAB is 6 substrings. So here what we need to do, as here calculated substrings, Similarly, we'll be calculating it for the others string as well, AD, BAD and all. So here what we need to do, the string substrings which we have calculated for the particular string, right? We need to check that whether that particular substring is hasn't come in any other substrings. Let's say for CAB we have calculated. CAB we have calculated. So you can see that for AB. So when you calculate for the other substrings as well, so you won't be able to find any AB substring that can be possibly created from other strings that are possible, right? So for AD, what are the possible substrings? A and AD. For BAD, what are the possible? B, BA, BAD, then A, AD, then D. But AB is not possible. For C, it is not possible. So you can see that for the string one, AB is the answer, right? So here you can use map for storing the frequencies and for checking that when the map count for the particular substring is 0, means that can be one of the answer. So here there is a possibility that in for the CAB, let's say other strings are there, so that particular string might be having two or multiple substrings, right, which are not present in other substrings. So at that time what we need to do, they have given that we need to return the lexicographically smallest one. So at for that we'll be checking the string length and the strings. So that thing we need to check. So let's see, directly see the implementation. I don't need to be dry run for more such tests because you got the approach, I think. Just see the proper implementation in a structured manner. So what I have done here, I have taken the size of the array and map string int, which will be storing a particular substring. So what we have done, for all the strings we are traversing in the array, after that for particular strings we'll be storing the calculating substrings possible. For the CAB we are having C, then CA, then CAB, then A, then B, then AB. This possible substrings are possible, so we are storing it in map and incrementing a counter. So this is the thing that we are storing here. For all the strings that are present in array, we'll be storing all the frequency of their substrings. After that, what we need to do, we have created a vector string for storing our answer. Similar thing, we're traversing the array, we are traversing the every string. So here what we need to do, for the first string, what I will say, we will be decrementing the count of that particular all its substring. Let's say for CAB, whatever the substrings we have calculated, now what we will be do, we will be decrementing the count of all the substrings. The reason is that we need to check for the in the remaining substring that whether these substrings are present or not. If it is currently present in map and now we are checking that, it will show that it is present in map, right? So we need to decrement it and then check for the remaining one, and after completion of that task we'll be again incrementing it, because it will now it will be moving to next string, right? So what we are doing, we are doing the same thing, we are decrementing it, right? Now decrementing hit here the string for the for every strings whatever the substrings are, we are decrementing their count. At next what we need to do, we're traversing this particular string and we'll checking that whether it is present in the map or not. Let's say CAB, let's say AB is not present in map, so its map count will be 0, right? Now, as they have told that lexicographic smallest one we need to check. So I have created a string for storing the current storing whatever substring we are storing now, and the global one, which is the previous one that we have encountered, which is the possible one. So if our answer dot length is 0, means we haven't encountered the other possible substring which is not present in the other strings. So it's if the string length is 0 for the previous one, means this is the one which is having a map count 0, and this is the one which is can be a lexicographic smallest one. We will store it in answer. Let's say if this is not 0, means already we have encountered some one of the string which is also can be an answer and which is not present in other string. For that what we need to do, we need to check the one which is having a minimum length. So let's say if the current one is having the minimum length, then our answer is current string. Let's say both the strings are having the same length, then we need to check for the strings. Let's say our current string is less than array, means which is like very smallest than the previous one. So we'll be storing that in answer. At last, what we need to do, as I mentioned that, let's say we are calculating for the CAB. So we have incremented their count, all the substrings count, then we have decremented for the CAB and check for the individual substrings in the remaining string, right? Now what we need to do, we need to again reset the map and store the CAB substrings count again, And now we'll be moving to next string AD. Now we will be decrementing their substrings count, right? So here we are incrementing it and storing the answer for the first string, whichever the possible. So for first one, it is AB. Similarly, moving it. If we do not get any string, we will be simply printing empty string. So this is the one that I have declared answer global one as empty. So this is just a basic one, and this is a very easy problem. And I can say it is just an implementation one. Don't need no need to uh, think that much for this problem. Just proper implementation with structured implementation technique is required to implement this. Hope you got the approach. So let's move towards the interesting problem from this contest and the harder one, which very few people is able to solve. The problem is the fourth problem, that is maximum strength of k disjoint subarrays. So let's discuss. This is the classic DP problem. I will say this problem requires a good understanding of take not take DP concepts. I will say whoever has done a take not take DP concept can able to write at least recursive solution. Acceptance not acceptance is the second step, but if you know take not take, then this can be a problem for you to solve. If you won't able to solve this in context, then here I am able to I am here to explain you. So let's discuss this and understand this. So let's say we are given a zero index integer array of nums of length n. We are given a positive odd integer k, right? What we need to do, we need to maximize the strength. So we need to divide our array into k disjoint subsets. The thing is that array is given k disjoint subsets. We need to break into array. We need to break array into k disjoint subsets, and we need to maximize the strength. The formula for the strength they have given. Strength is nothing but the first sub array that we have built, right? Calculate the sum of that sub array, what you have break down, and multiply it with x. Then the second sub array you have encountered, multiply it with x minus 1, but now you need to subtract it. Then third sub array that you got, add it and multiply it with x minus 2, but here you need to add it. So minus plus minus first thing they are showing. So we need to break the sub arrays, so need to use x minus 1 x minus 2. I will say here the thing is that for for uh, diverting you, they have given x here. X is nothing but the k. When whatever the count of the k is there, it will be here, then it should be k minus 1. Mean nothing but what they are doing, they are decrementing the k value. So this is the biggest in that k is one of the changing parameter, right? And we are traversing the array, and I index is the changing parameter. So everyone can think in terms of n cross kdp, right? N is the size of the array and k is. So I will try to explain it with the help of this example. Let's see. 1 2 3 minus 1 2 k is equal to 3. I I found this question is quite interesting and very helpful for the one who hasn't started DP, but they for them this can be a very good problem to understand take not take concept. So the nums is 1 2 3 minus 1 2. 1 2 3 minus 1 2, right? Our k is 3 here, right? 1 2 3 minus 1 2 1 2 3 minus 1 2 k is equal to 3. Let's discuss. So here what they are given, we need to maximize the strength. So what are the sub arrays that we can form here so that we can get the maximum sum? So here you can see that one negative element is there, and in formula we are having plus minus thing. So second sub array should be negative one, mean with the negative sum can be a good for us, so that it will be because if the sum is negative for the particular sub array, then after multiplying it with minus, it will be positive, right? So sub array that can be possible here is 1 2 3 1 sub array, right? Correct. This is one sub array that is possible. Another one is minus 1 that I am talking about, negative 1, right? Negative 1. And another one is 2. Correct. So these are the possible three sub arrays. Now apply the formula. A formula is strength is equal to sum of the first sub array, that is 3 plus 2 plus 1 6 into x. As I mentioned that for diverting you, they have told that x is nothing but k, starting k, so 3. Now Second step, at second we need to decrement it, then plus minus plus minus plus thing, right? Here you can see that minus plus, right? So here sum for this second subarray is minus 1 into, now our k is 3 minus 2, it is 2, right? We need to break the array into three, means k sub arrays, right? This is first, this is 2, this is 3, right? So 3 2 now, right? Now we will be calculating for the third array sum is 2, and our, now how many sub arrays we left with, last one, that is 1. So here you can see that our sum is 6 3s are 18, right? Plus, as minus minus becomes plus, 2 plus 2, the answer is 22, right? You can see 22. So this is a very easy one to understand, right? So now let's see how we are gonna move. So here first see the constraint. The reason is that whenever you see constraint, you get that which is the best approach that we can use for the particular problem. So here you can see that n into k is 10 to the power 6. The reason, this is the reason that why we are applying dp is here. If n value might be 10 to the power 5 or something, right? Then we won't able to apply dp because 2 cross dp fails here. So n cross k is 10 to the power 6. That's why we are applying dp. So here we are having for every step what we are having. We are having two choices. Okay. So dp table is n plus 1, right? I will take one extra size and k plus 1, right? Two changing parameters. One is index of the array and for and k, because k only k disjoint sub arrays can be possible, right? They have mentioned that you need to select k disjoint sub arrays from num such that their strength is maximum. Only k breaks can be done, in the k sub arrays can be done. So here two choices are there, whether to take this element or not take this element, right? But here is the catch. Whenever you are, let's think that you take not take, it's the good thing, right? Take element, not take it. And for the particular subarray, we can do this. But here, I got to know that after the contest, I got to know that many people got TLE for this when they were tried to apply directly n cross k solution. Here, you can do small optimization that no one can tell you. The reason is that because if they fail to do that optimization, then they got TLE. The reason being that here the one more condition is that for whenever here you are taking that take not take, right? But there will be a condition that is we need to break in k disjoint subarrays, correct? But whenever so for this there might be one state as well, right? So here what I have done, I have done the small optimization. The small optimization is I have also created one more column with the two states. The two states is that whether we can, after taking or not taking that element, whether we can break the subarray there. The reason is that we need to choose the subarray optimally. The reason is that here we can see that minus one subarray we have chosen, which will be very useful for us because it whenever it multiplies by minus, it will give us a positive value, right? So we need to take care of that condition as well, when to break it and when to not. So we have two choices at particular step as well, whether to break it or not break it. Ultimately, for in total we have three choices. I will tell you. The reason is that for the particular element, right, what you are having choices, whether to take it, correct? Take it. And one more thing is there, take that element and break the subarray there. Take it and break it, correct? Second condition is that take it, take that element, take that element, but don't break it, but don't break it, correct? Don't break it. Third condition is that simply don't take it. Don't take it. DT, right? Don't take it. These three are the conditions, which is a very useful thing. So here you are thinking that here I am having a n cross k dp, n cross k cross 2. So whenever I will say this dp is nothing but n cross k cross 2. And as you can see that we always treat a constant number, right? So this is not n cross k. This is n cross k cross 2. But when we, as we use asymptotic notation, this is ultimately n cross k only. So what we have done, we have optimized our code. The reason is that people got TLE, they are missing this condition only, that when to break it. So every take condition is having two choices: break it or don't break it, right? And otherwise not take it. So these three are the important conditions. Let's see the code. I think you will get approach what I am trying to say with the help of the code. So here what I have done, I've created the 3D DP with k plus 1, n plus 1, k plus 1 and two states, break not break. I always think in terms of that. I have 1e5, I filled the DP 3D DP with 1e1, 1e15. The reason is that here you can see that I can fill with it minus 1. The reason that minus 1 is one of the possible answer. Even I am having a habit that always fill the DP table with minus 1, but the many people failed here as well. They failed with minus 1, but don't uh, take care of this condition that answer should be minus 1 as well. So I have filled with maximum value that can be also 1e15. So here you can see that nums of I is 10 to power 9, right? And even 10 is 10 to power 4, 10 to power 13, 10 to power 15. Anything can work. So maximum size I have put. So this is the thing. And at I have, for the indexed, I have starting with 0 index, then I am a count subarray. How much total subarray we have count so far? Because we need to count total k subarrays only, right? And what is the state of the DP, whether it is 0 or 1? The reason is that whether to break the array or not break. So we will be starting with not break, right? And nums k and dp, these are the parameters we are having. Changing parameters are nothing but idx, count subarray and state, n cross k cross 2 dp, right? Always think in terms of recursive manner. Whenever you solve dp, always think in terms of recursive, because in this problem writing a iterative approach is very difficult, and beginners and even experienced people will face that problem. So always think in terms of recursive. Recursion is the best way to implement dp, I will say, means for understanding properly. So here these are the base condition. The base condition is that whenever our count sub array is k plus 1, as you mentioned that you can break into k sub arrays only. Whenever it reaches k plus 1, we simply return 0. Got it? And one more base condition can be that whenever our index, we reach the end of the array. Whenever we reach the end of the array, return any negative value. So we will be returning minus 1e15. And this is the memoization condition. DP of IDX count subarray state. Whenever means if we already travel that, or we can say covered that subarray, we can say sub problem, simply return that. So this is the memoization. Always trust DP, right? The main thing is that whenever you learn DP, always trust its conditions. Always trust DP, because memoization will do work for you. So this is the thing. Everyone who has done dynamic programming will understand this. So now, at current position, what are the remaining subarrays we are having? So k minus subarray plus 1, count subarray plus 1 is the remaining subarray. So here you can see that this is nothing but this condition x I have calculated here, means total subarray. For the initial one, our value is k only, then it should be k minus 1, then k plus 1. So we'll be calculating the remaining subarrays that we need to break the array into subarrays, right? Let's say here I have checked that when our count subarray is even, means the reason is that here what we need to do, we need to first add it, then minus, then add, then subtract. Alternative signs are there. So for this condition I have checked here, if our count subarray is even, means at that time we will multiply remaining with minus 1. The reason is that we need to subtract it with minus, we need to subtract here because of this condition. So for this I have taken this condition, and I have taken the maxi, which is storing the int minimum value. Int minimum, so we can say minus 1e15, it's minimum value. So we are storing the maximum one. So let's say we are having states. States are 0 or 1. Let's say our state is 1. Means we have already started the sub array. So we have started the sub array. 1 means started. 0 means breaked. Right? So first state is that. Take the current value, move to the next element, and don't break the array. Still move and continue the sequence and continue that sub array. Right? So here we don't increment subarray because we are following the previous subarray only. We are not breaking it. So we have included the element, we haven't break it. That's why element is one. Our state is one only. Next step is that take that element and break the subarray there. Condition that I mentioned: take, break, take, not break, not take. So first condition is take, not break. One is state. Take and break the subarray there, right? And the third condition is that as our state is one, means the possible condition is that as our state is one and we are not taking element, means if we are not taking element means ultimately we are breaking the subarray, because subarray is the contiguous thing, right? When you are not taking it, ultimately we are breaking it, so we have break it. Zero we are the zero is the state here, right? So for the state one, the thing is that here is the only change. uh, the first thing is take it, don't break it. Take it, break it. Don't take it is nothing but break it, because state is one, so we need to change the state only, that is zero. Let's say our state is zero, means we haven't started any subarray yet. So let's say we will be taking this element and we are starting a subarray, right? This condition says that. Let's say we are taking the element and we are breaking the subarray theirs only. So here what we do, we will be incrementing the count subarray, right? And now the third condition is don't take element, as our state is still zero and we are not taking the element, means ultimately state is zero. It won't we won't need to increment the count subarray thing, because we are not breaking here. We already had a break condition, we haven't started anything, so zero. But in state one we are having a state one, means we have already started with the subarray, but if we are not taking element means we are breaking the contiguous condition that subarray holds, so we need to increment the counter and break. So this is the three condition: take, not break, take, break, and not take. This thing, always this, no, always think in terms of this: take, break, take, not break, don't take. That's it. And at last we'll storing it in dp table and we're returning it. Hope you got the approach for this problem. This problem is not difficult, I will say. If you know take, not take dp concept, then just small optimization is required. That state thing, many people fail to do that. They have the earlier n cross k solution that everyone tries to create all subarrays, calculated it. That is not the wrong one, I will say, but it gives TLE because of the something that you are not optimizing it. So I have created one other column, that is two column state column, which is having two states, 0 or 1. As it is having a two states, it is a constant one, so ultimately our complexity n cross k cross 2, which in asymptotic manner it is n cross k only. So we are not increasing the complexity, we are optimizing the solution. So we have followed this formula and we are able to solve this. Hope you got the approach. And uh, always I will say one of my suggestion that whenever you start with the DP, always try with start with the take, not take concepts and zero one knapsack type of problem. So this will help you to analyze the DP properly and you can move towards the harder problem. So I think take, not take is the main concept here: dynamic programming and small optimization, state optimization. Hope you got the approach. I tried to explain the approach in a very efficient manner and tried to code the uh, thing in a proper manner so that you can understand it properly, because very few people able to solve it, only 375 people able to solve it. So I thought try to explain it in a proper manner and take this. Even dynamic programming is my favorite topic and I love to solve dynamic programming problem, and this is the very good problem. So let's as I have explained, try to implement it by yourself. Here they have diverted you by changing the taking x is nothing but k. Every time k is decremented means we need to divide. Here they have mentioned that k is the distance sub arrays, right? Hope you got the approach. Hope you understand the problem in a proper efficient manner. If you watch the video till this point, please don't forget to like, share and subscribe to my YouTube channel and stay connected for more such lead code, code shape and code forces contest analysis. Thank you. Happy coding.